Hey everyone, welcome back to the Basic Aeronautical Knowledge series. Today, we're talking about airframes. The airframe is the fundamental structure of an aircraft. It provides shape, support, and strength, allowing the aircraft to withstand aerodynamic forces, weight, and stresses during flight. In this video, we'll have a look at different components that you will need to know. Let's get into it. The airframe is the fundamental structure of an aircraft. It includes all the major components that give the aircraft its shape, strength, and aerodynamic properties. Let's break it down. The wing generates lift, allowing the aircraft to fly. The horizontal stabilizer provides stability in pitch, preventing unwanted nose up or nose down movements. The vertical stabilizer and rudder controls yaw, keeping the aircraft in balance. These components work together to ensure smooth, controlled, and safe flight. Right? Now, let's take a look at the front section of the aircraft, where we find two important components. The propeller, this is what generates thrust, pulling or pushing the aircraft forward through the air. It works by creating a force by accelerating the air, just like an aircraft wing, to produce motion. The cowling. This is the outer covering of the engine. It serves several purposes. It aids in the aerodynamic properties of the aircraft, protects the engine, and directing airflow to keep the engine cool during flight. Let's have a look at the primary flight controls, which are the main control surfaces that allow the pilot to maneuver the aircraft. Ailerons are located on the trailing edge of each wing, ailerons control roll. When the pilot moves the control stick left or right, the ailerons move in opposite directions. One goes up, the other goes down, causing the aircraft to roll or bank. The elevator is found on the horizontal stabilizer. It controls pitch. In simple terms, moving the nose moves up or down. Applying back pressure on the control column moves the elevator up, raising the nose. Applying forward pressure moves it down, lowering the nose. Rudder is located on the vertical stabilizer. The rudder controls yaw. It is controlled by foot pedals and helps maintain balance during flight. Each of these controls plays a crucial role in keeping the aircraft stable and maneuverable. An aerofoil is a specially shaped surface designed to generate lift when air flows over it. This fundamental aerodynamic structure is critical for aircraft wings, helicopter rotor blades, and even propeller blades. Let's break down the key components of an aerofoil. The leading edge is the front part of the aerofoil that first meets the airflow. It plays a significant role in how air is directed over the surface. The upper surface is the curved upper portion of the aerofoil. Due to its shape, air moves faster over this surface, creating lower pressure and contributing to lift generation. The lower surface is the flatter underside of the aerofoil. Air moves more slowly here, creating higher pressure, which works in combination with the upper surface to generate lift. The trailing edge is the rear edge of the aerofoil, where the airflow from the upper and lower surfaces meets. The design of the trailing edge influences lift, drag, and overall aerodynamic efficiency. Now that we understand what an aerofoil is, let's break down some key terms related to its shape and structure. First, we have the chord line. This is a straight line running from the leading edge to the trailing edge of the aerofoil. It serves as a reference for measuring the angle of attack and aerodynamic performance. Next is the mean camber line, an imaginary line that runs equidistant between the upper and lower surfaces of the aerofoil. This line represents the overall curvature of the wing. Then we have the maximum camber, the largest distance between the chord line and the mean camber line. This measurement reflects the aerofoil's curvature, which directly influences the amount of lift it can generate. Right? Wingspan and aspect ratio are key factors that influence an aircraft's performance and efficiency. Wingspan is the distance between the two wingtips of an aircraft. A longer wingspan generally allows an aircraft to generate more lift, which helps it take off and land at lower speeds. On the other hand, a shorter wingspan enhances maneuverability, making it ideal for aerobatic and military applications. Aspect ratio is a measure of an aircraft wing's efficiency. It's calculated by dividing the wingspan by the average chord or width of the wing. An aircraft with a high aspect ratio has long, narrow wings, reducing induced drag, which is drag caused by lift production. This results in better fuel efficiency and longer range. Conversely, an aircraft with a low aspect ratio has short, wide wings, making it more maneuverable but less efficient in cruise flight. When designing an aircraft, engineers carefully balance aspect ratio and wingspan to achieve the desired performance. For example, a commercial airliner typically has a high aspect ratio and long wingspan to maximize fuel efficiency and range. In contrast, a fighter jet features a short wingspan and low aspect ratio, prioritizing agility and rapid maneuvering. Understanding these aerodynamic principles helps pilots and engineers optimize aircraft for their specific missions. A propeller generates thrust by spinning through the air, creating a difference in air pressure between the front and back of the blades. As the blade spins, it pushes air backwards, creating a force that propels the aircraft forward. This force is known as thrust and is what makes an aircraft move through the air. The faster the propeller spins, the greater the amount of thrust it generates, allowing the aircraft to fly faster and climb higher. In simple terms, thrust is generated by the propeller, accelerating a large mass of air through a relatively small distance. Our flaps are an important feature of an aircraft's wings that can greatly improve the safety and efficiency of takeoffs and landings. They are hinged surfaces on the trailing edge of the wings that can be extended to increase the wing surface area and change the wing shape. By increasing the wing surface area, flaps can generate more lift, allowing an aircraft to take off and land at lower speeds. This is particularly useful for aircraft operating on shorter runways or in areas with high altitude or hot temperatures. Flaps also increase the wing's drag, which helps an aircraft slow down during landing, making it easier to touch down on the runway and come to a stop. Typically, there are a number of stages of flap that deploy the control surface to preset degrees. For example, this aircraft can deploy 3 different stages, including 10 degrees, 20 degrees, and 30 degrees. Thanks for watching this episode of the BAK series. If you're just starting your aviation journey, make sure you subscribe so you don't miss out on more essential lessons to help you ace your flight training, and check out teamaviation.com.au for more resources. Hit that like button if you found this useful, and leave a comment below with what you want to learn next. See you in the next video.